Hello, everybody. So let's talk about some week 2 stuff today. So the last lecture we had was covering the Unreal navigation system, and then there was a lecture to watch in here just about general state pattern stuff, as well as setting up a simple state machine in an experiment. For this week's assignment, that's actually going to be digging into that state pattern a bit more and actually seeing how you can build different types of state machines. Then we have a discussion for kind of game designers look at how state machines could be done. And what it's going to ask you to do is basically take any game you're currently playing or are interested in and try and think about how you could break down those different states that it could use. One of the easiest ways to do this is taking a look at either the character that you're controlling or maybe an enemy in the level and choose some different states. Like, is it just going to sit there and idle? Is it going to sit there and patrol? When the player gets close, does it start chasing the player or pursuing them? When it's attacking, what would those different things be? So you're going to describe kind of what the different states would be, as well as list any exit conditions for that state. What I mean by an exit condition is what would need to happen for it to change from its current state, the state you just described, let's say idle, to another state. Let's say there's a state for walking or something. One of those exit conditions would be, well, player pressed a button and it's now supposed to be moving forward. Things like that. There is no real right or wrong answer as you're breaking these down, so please keep that in mind and just try and do your best to kind of describe what those states are and whatever exit conditions you can think up of. It has to be a minimum of 5 different states. So describe all those states, even if it is more than 5. You don't have to describe every single state of the game, but it just gives you a good starting point for that. This post does also require a reply to another student's breakdown of the states. Please try to make it something useful and don't just leave it as something like, looks great, good job. Try and actually think of a state that they might not have thought of, or maybe think of an exit condition that they might have left out. Things like that actually provide constructive criticism. All right, and then after the discussion post, there is an actual assignment for an NPC with a state machine. This one will actually be providing a state machine for you to use, and we'll be talking about that a bit more in next lecture. For today's lecture, we'll just be kind of looking at how we can set up a simple state machine and get that kind of state concept into your head. So as I mentioned, there is this experiment which isn't due for another couple of days here for the simple state machine. And the state machine itself, if we take a look at kind of what that experiment will have in it, there's links to just Unreal tutorials as well as the documentation reference. Those come in super handy if you ever notice we're using something that you don't know what that does or how to use it. Definitely always use the reference material. So this will actually set up a simple lamp state machine script. And it's a bit of a walkthrough kind of describing all the different stuff, describes the problem, breaks it down into what are we trying to solve, what kind of the different states things would have, specifically covering this lamp topic. Talks about creating a data model, and then gets into the actual lamp state machine. For today's purpose, we'll go ahead and do something similar, where we're setting up a very simple state machine that it can have certain things run when we have it working. Rather than doing the same exact thing that this experiment will walk you through, we're going to take a look at, let's do a door instead. So for this, I'm going to go ahead and open up a project. just an empty one from Unreal. Launch the engine here and create a simple state machine setup. I'm going to start with a game since we're in the game design degree. And as far as a template that I'm going to start off with, just give me a simple player that can like kind of walk around and things like that. I'm going to start off with this third person template. So we have this character in a level that will add a door to that it can actually walk up and walk through and stuff. Next up, we'll go ahead and give this a name. We'll call it simple door state machine. And it's longer than 20 characters. That's good enough. All right. So since we started with this third person, we actually have a character that we can walk around with and stuff like that. Let's go straight into creating a simple door for us to use. Now, please don't judge my art skills as I'm making this door. I'm going to go ahead and just create a, I'm going to expand this and lay this out a little bit better. Our blueprints are held right in here in this third person BP blueprints. Let's create a door here. I'm going to start with a blueprint class. It's going to be an actor in our scene. And let's call it BP for blueprint door. All right. So my door, and for the purposes of this, I do have a door asset somewhere, but now let's just use primitives. All right, let's just do a box cube, and we'll do a sliding door. So we'll make this kind of thin, like a door. And I was trying to switch to the scale tool, but I renamed my mesh here. 1 second, this is door. And make it a little bit taller. And we've got a door. All right. So I want to be able to open this door and close this door. Let's have it just kind of move up. That'll be our easiest, like that, as we open it or close it. So we'll just have it start here. When it's open, we'll have it up like that. So we see it's moving up 200 units as I'm doing that. All right, so let's reset it back to 0. And what I'm going to do is just create a simple variable to hold that 200 offset for me. And this will be a door open offset. And we'll call this, we'll set this as a vector, since we'll be using it as a position offset. Compile, and we'll say 200 in the Z will be open. All right. And we can just even add one for door closed offset. Which would just be 0, 0, 0, since that's with the door closed. All right, just a couple of other things I want to have on this. I want it to detect my player and have like a little bit of a area around it so that it can detect when our player enters a volume. We'll use just a simple box collision for that. We'll make it a bit bigger. Let's say for X, we'll go 300. That's a bit big. 150. And for Y, let's make it a little bit wider, maybe just 50. And let's also make it a bit taller so it fills up like the entire area of the door. Let's do 70 for that. All right. Now we'll notice if we grab our door and are moving just our door component, we're setting a local offset right here. So if it was at 200 for its local offset, it's up there, but our collision volume still stays at its origin. So wherever we place this entire asset, our trigger volume won't be moving. We're just going to be moving this door up and down. All right. Let's go ahead and drop one in the levels so we can compare its size to our player and stuff. And let's spin it. And let's also just throw a block on each side of it. We already have this block right here. We'll just move that kind of like that. And Control W to duplicate, throw one on that side as well. And I am by no means a level designer, so please don't judge me if it's not lined up perfectly. For the door itself, I'm going to go back into it and we need to add some more functionality to it. I do want to point out that this is letting us know lighting needs to be rebuilt. The reason for that, I don't know if you guys are aware, but these cube meshes are considered static. So their lighting is what is called baked or pre-built. We could adjust those to movable so that their lighting is always dynamic. Could also just build all the lighting, but that generally takes a little while, and having just such a small level, the dynamic lighting for this one wouldn't be very expensive. Let's play and make sure player can't get through. Okay. So making sure that that's working and blocking our player from moving. Next thing I want to do is that when my player enters that volume, it's going to tell our door to open. So for our trigger box or box collision, we'll even rename it for trigger. And we'll set up some collision on it and tell it to respond. So we'll go to the collision. For collision presets, I only really want it reacting when our player begins overlapping with it. So we can do overlap only pawn. Play and no change. But now we have our collision set up. Let's handle what happens when something begins overlapping with this component. When it begins overlapping with the component, we can tell it to go ahead and open the door. For that, we have our door open offset, door closed offset. Let's just go ahead and set our door's position. Set relative location. So relative to its starting position, or 0, 0, 0. We'll change that to open. Compile, save, play, and we got it to open. We're able to walk through it. Problem is, each time we walk up to this, it kind of closes. It's never closing. Let's say we had something where we wanted to be able to push a button on a wall, or that box wasn't just like an automatic door that opens or closes. We're going to move our trigger around and change it so that there's a specific spot you have to basically use as a button for it to open. I'm going to even add simple cube in here for open button. Put that in the trigger and scale that down a bit. 0.2, 0.2, and 0.2. And we'll adjust our trigger again as well. And we'll also pull this forward a bit. I want my button attached to my trigger, so I can just move this one and it moves them both. I'm just going to put it up like that, so it's kind of like a button on a doorbell or switch for it. And it is cool outside there. So we got our button over here. When we walk up to it, opens the door. If I walk up to it again, I'd want it to close the door. So here's the part where we have two different states. We have a state for when it's open. We have a state for when it's going to be closed. We could go ahead and just add a simple bool to track this, since we're only doing the two different states. But if we wanted to add maybe like a locked state and require the player to get a key or something before it can unlock and things like that, we'd want it to be a little bit more versatile than just having a bool. So what we're going to do is use an enum to define the different states for the door. Let's go ahead and right click, and I always forget where the enums are. They're in miscellaneous, aren't they? And let me hide these meeting controls. No, they are under just blueprints for enums. Yeah, enumeration. So let's add an enum for this, and let's call it e_door states. And let's just start out with the two simple states for now. We'll just add two things in here. One is for open, and another one is for closed. Now, a common thing with enums, they'll often do things or they'll often write the names of the enums inside all caps. So let's say open all caps, closed all caps. As to why that is, that's just a very common coding thing that I've noticed in the industry. All right. So we've got something defining an enum for the different states. Let's have our door hold a variable of that enum, and we'll call it current state. Instead of a vector, this will be our enum type, e_door states. Make sure to compile, then we can set it to a default. Default starts off closed, so we'll say closed at first. And then we'll let our, we'll actually change it and set up a tracking system for that. We've got a variable called current state. If we want to change its state, rather than just immediately telling it to open the door every single time, I'm going to leave this here. Just we're going to change this. I'm going to break the link to that. And we'll add some code in here first. When we begin overlapping with it, I'm going to ask it what its current state is before we run code for it. We'll go ahead and get the current state, and we can then switch based on this state. switch will actually route it based on this variable to the specific exec that you want. So when it's in the closed state, we would want it to just go ahead and open that door. When it's in the open state, we'd want to do something similar where we're changing the door's relative position. And not sure why Control-C, Control-V didn't work there for a moment. Must have clicked off. But instead of the new location being open offset, we'd do the closed offset. Compile, save. And we play. When we enter, opens that up for us. We're able to walk through it. If we enter this again, you see it's not going closed. Reason for that, let me try and show this here. We're actively actually debugging this right now, so we should see the exec lines run when they're actually fired off. When we enter it, it's going through that closed one. Our current state still thinks it's closed. We want to make sure that that gets tracked properly. So when we're finished with all our open stuff, let's go ahead and set our current state to closed. And vice versa, when we do actually close it, or when we tell it to open and the closed state runs, we'll say it's now open. All right. So we run through that, opened it, run into it again, and it closed it. And we see it's running all of this code every time we're just overlapping with it, essentially. There's a better way to do this rather than for every single state we add another line here and just have more and more added to this one simple function. We could wrap up the individual state functionality into their own functions and actually change which function is going to run the next time it begins overlapping. So let's go ahead and do that. Let's set up a couple of just individual functions here. I'm going to grab this stuff for when it's telling it to close the door. We'll just collapse this to a function. And this would be considered, let me rename the function, not new function. Where's the name? Oh, yeah. We'll call this for open state. It's going to run that code. For the closed state, it would run this code. And I just added a new function. I didn't collapse this one like I did with the other one. We'll just grab it from the event graph, Control X, Control V, move that over to the function we just created. Compile, save. And then for closed, we'd call the closed state. The big problem is, like, it's still running this switch and having to actually branch based on what state it's currently in. Well, there is a way to group these things together so that it can just immediately call one function or the other based on what state it currently is. And that can actually be set up using an event dispatcher. So event dispatchers are like a way of having a variable for a function or function variable. we're going to create one, and we'll go ahead and call it current state. Oh, and didn't like that. Why didn't it like that? Do I already have something named that? Name is already in use. Oh yeah, I have the variable that we created for our enum current state function. And we've created this dispatcher. We'll, rather than switching based on this enum for which state it's going to run, on begin play, we'll say our current state function. We will bind it to a specific event or function, and we'll just bind it straight to the closed state. We have to, since it asks for an event here, we can go ahead and create a custom event, or there's actually one called create event where it gives you a drop down to select any functions. So we'll say it is in the closed state to start off. And rather than doing all this stuff, clear that out. When it begins overlapping, what we'll do is just tell whatever this current state function is to run. We'll actually call it and run it. Now, the other part I need to go with this, since we were changing our state by setting that enum and having it branch based on that, rather than doing that, we're going to need to update what this function is bound to. So at the beginning, we're saying, always run this closed state function. In order to keep this simple, let's just create a new custom event here for setting our state. Set state, we'll take in an enum, our e door states. And for that, we'll just call it new state, or state to change to, next state. We can do the branch and stuff here, or switch based on this. One thing we'll always do, regardless of what new state we set, we're going to want to clear our current state function variable out, or our current dispatcher out. So just like there is a bind event too, there's also a unbind. Unbind all events from our current state function. So that's basically clearing our dispatcher out so it no longer knows what event to call. Then based on this, we'll be binding it to the specific function. So when it's closed, we bind it to the closed state. When it's open, oh, not that. Control V, not Control B. We'll bind it to our open state. So we do have this set state, just clearing that variable out for us to use, but our game logic just always uses whatever the current state is. So if we check this out, should run into it, run that state function, run into it again, and I never called set state. I did the logic here for it, but I never put that in the individual states. So when it is in the closed state, and we basically tell it to open, we'd want to not bind, set state, tell it that it is open. And let's go over to our open, and rather than just setting current, we'll call that same set state function for closed. All right. So we play now. We hit that, opens, hit it again, closes, opens, closes. And what this does is it allows our actual individual state functionality, and well, our class functionality stays just simple. All it's doing really here is associating which function to call when it's told to run, or when it's told to overlap. And then our individual state function can just focus on what does it need to do when it's told to change during this state. And our transition condition or exit condition here would be considered this when it begins overlapping, when something begins overlapping with the trigger. It would just transition from the state. And based on the current state, if it's in the open state, we see it going to that closed state. If it's in the closed state, it goes to that open state. Pretty simple with the two states. The reason why it may seem super simple and like we didn't really need to overcomplicate it with the set state code or anything like that for right now is because we are doing just a simple, when it overlaps, always switch which state it's in and stuff like that. Let's say we had another thing in here. Let's go ahead and tell our character that it's got a bool to track whether it has a key or not. Has key. All right. With it, we'll default it to false. We'll go ahead and throw a simple key in here. We'll just do an actor, and we'll do just a simple sphere that we're going to place on the ground over here. Call it BP key. And we'll add just a sphere. And we'll let it overlap with the pawn. Overlap only with the pawn. And when our player hits one of those, so we'll go to our character. We'll look for actor begin overlap. Doesn't have one on the graph already. Actor begin overlap. When it begins overlapping with something, we'll check what it's overlapping with and make sure that it's key. Cast to BP key. Could have done a tag, preferable to a cast, but good enough. If it does hit a key, we'll say it has a key now. Turn that to true. And just to test this, let's add a simple tick. And we'll print out the value of our key each time. All right. So when we're playing, you see it doesn't have a key, and it would help if I add a key to the level, not just create the blueprint for it. Play. So it's false. We see that is changing the value for our character. All right. Next up, let's add a locked state for our door. So in our door, let's add another state. There's a couple of things we'll do for it. We'll set that up in our enum. New locked, and all caps just to satisfy that. And now our door, we'll go ahead and create a function for that state. Locked state. We'll set our current state default to this locked state. Compile, save. And while it's in this locked state, what it's going to do is we want it to actually ask our character if it has the key or not. So our other state's very straightforward. When it's open and we hit it, we just tell it to close. When it's locked, though, we'll want some additional functionality here. We're going to do a little bit of a cheat just to get access to our character in here rather than passing it all through. We're just going to get player character and cast it to the third person character so we have access to its variables and stuff. Has key. And we'll branch based on that. If it does have the key, then we'll change it to, let's go straight to open if it does has the key. Open, not call that function. Set state open. All right. The other thing we'll need to do is we see each state right now is kind of telling it what to do before it sets that state. So we see the closed state function does actually open it all up. We'll throw this in that locked state as well as part of the stuff that needs to run as it's entering our open. Okay. And almost didn't connect that. Cool. If it's not open though, let's just go ahead and print a message or print a string. Door is locked. Need to get a key. All right. So, last thing I need to do, I think our door beginning play was just always binding to the closed state. Let's go ahead and just set state, since we moved that functionality there, to locked to start off with. We now have a new option here for which function we want to use. Do the same thing. Oh, didn't mean to copy that in there. Let's copy this. For our locked, it'll be calling our locked function. All right. So it's letting us know we don't have a key. We run into that, and it is saying it is locked. I'm going to get rid of that debug print on tick, just so that's not cluttering up the screen. So when we run into this, door's locked, need to get a key. We get the key. Ooh. And forgot to destroy that key after we hit it, but not important since it's always just setting it to true. And we see it now switching to the other things. So taking a look back at the individual states, the state itself now just has its specific code for what it needs to focus on. Our lock state has two different, well, still just the one exit condition of if the player does pick up a key and hits it. But we also have additional functionality, just a little bit more than only responding when it's overlapping. It also checks that key and can focus on that. But our other states themselves, for when it is open or when it is closed, don't need that extra additional check. So they're a bit simpler and can focus on just what they need to do when they're told that their state has been run. Does that make sense for you guys a little bit of how the state machine could be working and things like that? You guys have any questions so far?
I don't have any questions.
No. What about you, Sean? Do you have any questions?
I don't think so.
Don't think so.
Looks good to me.
All right. So this was just kind of a simple state machine where the state machine is still just built into custom functions inside all the door itself. We could add more abstraction to this, and we'll be taking a look at how that's done next lecture a bit more for the state machine that we provide you with. And that'll be component-based states. So rather than just being a separate function and having the switch every time we tell it to change the state and just assign it a specific function to call, we'll have multiple different components, each with all their own state code wrapped up inside of them. But that's getting ahead of us for today. Since this was just the simple state machine stuff and the nav agent with a state machine, and when we provide you with a state machine isn't until the end of the week. I do want to remind you guys that you have worked with state machines before if you have done any animations and stuff in Unreal. We could even open the animation blueprint up, which we'll just go to our character, see what animation blueprint it's using. It's on our mesh, and we're using the third person AniBP. Find that for us rather than searching through it ourselves. Open this up, and they have a state machine that they've named default. So the anim graph has this default state machine here. And what it allows is just this single state to be running, waiting for this transition to be true before it goes to another state. This is a great example and like visualization of how the state machine kind of works. If you were ever wondering how that kind of works and stuff. So when it is in air, transition from this idle run state to a jump start, then from jump start, after a certain amount of time's done, goes to jump loop. So we can test that right here and stuff and visualize it switching between these different states. The individual state is telling it which animation to play. This one has a more advanced one where it's doing the blend space, not just playing a single animation. This state, when it's in start, just simply plays plays the start animation. Pretty straightforward there. And our loop tells it to play loop animation and stuff. So this is that visualization portion of how it determines which animation to be playing at a time and things like that. That same thing is done with our state machines here, where we have our basic thing just saying, hey, give me whatever state you're currently in and play it. That's that same concept of the atom graph. Give me whatever current state you're in, and that's what we use to output. And inside that state machine, depending on which one it's been set to, tells it to play the right animation, checks the different transitions. When the transition gets to be true, it transitions to whatever other state it needs to. All right. So that is pretty much it for today. Just a little bit about the simple state machines, and we'll be digging more into that on Wednesday when we provide you with the state machine for NPC with a state machine. We'll be using it to kind of determine the NPC's behavior and what it's going to be doing. This one does have the state machine provided, as I mentioned. From the repository, we'll be giving you a starter project to start with, this state machine assets. And it'll be an exploratory assignment, because something you'll often do in the game industry is work with other people's code that you yourself did not write. And so you're going to have to kind of explore how this state machine is set up and take a look at a few different things on how that's all working in its current state. And then this document will walk you through how to add a pause state. For the lecture next Wednesday, I'll be doing something similar where we're adding a brand new state in there and seeing how we can do that, but not with pause, since the document kind of walks you through that already. We'll be taking a look at, let's go with like a follow state or something where it starts chasing a player. Sound good? Alrighty, that pretty much wraps it up for today, unless you guys had any other questions before I stop the recording here. Alrighty, I'll see you again on Wednesday then.